In this video, we will learn how to spot low-quality mesh zones with CONSELF. CFD simulation accuracy is strictly linked with the quality of your mesh. There are numerous different issues that can affect the quality of your mesh. In one of our posts, you can find our blog, we listed 4 of them that are the main ones. As you can see in this post, you can deal with uniformity, you can deal with aspect ratio, orthogonality and skewness. These are 4 typical problems you can encounter with your meshing procedure. So it is clear that having an instrument that is able to tell you if your mesh has problems or if it is good enough for your simulation is of paramount importance. With CONSELF you have such a tool, and I'm gonna show you how to use it. From my account page, open the Cloud Simulation Platform by clicking on the button. Now I will open a previously run case from the tab Simulations. My case is named City Area. I already completed my meshing procedure, and so I'm in my CFD step. The first thing to do is to load my mesh, and I will choose the last one. Once the mesh has been loaded, it's time to check its quality. Before even starting to set up the CFD, we have to check if we have any issue in our mesh. In order to check if we have problems in our mesh, the procedure is very simple. First thing to do is to open the left panel menu by clicking on this symbol and selecting the mesh file. In case our mesh has some problematic regions, we will find under the color menu different problem names. Here, as you can see, we have 3 different problems, one affecting cells and 2 others affecting faces, that can cause problems during our CFD simulation. In case your mesh is perfect, you won't see here anything but solid color voice. So this is the first way to understand if your mesh is good or not, if it has some problems or not. So again, in case the mesh is perfect, in this menu here, color, you will have only solid color. But now, let's say we want to understand where these problems are located inside our mesh in order to refine our resolution in that region and solve this problem. So I will take as an example here this problem, warped faces. In order to do so, we have to apply a filter that is called threshold. To do so, click on the plus in the top panel and select the threshold filter. We have to select the variable on which to apply this filter, and so since this variable is in the range from 0 to 1, where 0 means no problem and 1 means it is a problematic region, and we want to highlight only cells that have problems. So select 0.5 has the lowest value and then click apply. In this way we will extract from the domain only those cells that has a higher value than 0.5 for warped faces variable. As you can see, some of these cells appeared in the graphical window. We can color them by this value, and so under the menu color, let's select warped faces and let's click apply, then reset the range from 0 to 0.01. This way everything that is higher than 0.01 will be in red. So here you see our problematic regions, and in order to find out where inside our grid they are located, we have to activate back again the mesh and then assign to it an opacity value of 0.3. Clicking apply and hiding the menu, you see here in our region where these problems are located. This way you can discover where you have to refine your grid in order to solve your problems. And remember, you can apply this procedure to every variable in your file.